Welcome dear students, we are on the CEC Gurukul lecture and we are in the series of electronic circuit. Apart from that, we discuss about the many electronic storage devices. So today we will discuss one of the important energy storage device, that is the supercapacitor. As the name suggests that it uses the word super, and this this term we use in our daily life, like supercomputers, superconductors, super trains, super individual humans, super nutritionists, super specialists and many more. So this super indicates the extraordinary power, capacity of a particular thing. Like if we are using the capacitor which is having a super capacity, means having a extraordinary power, then we will call it as a super capacitor. Like the computer which is having extraordinary power or the capacity of particular thing, that it is a supercomputer. So in this presentation we will understand what is the superpower of a small component, that is a supercapacitor. Means we are having a small component but it will give the super output. So what is this supercapacitor? This supercapacitor is also known as an ultra capacitor. It means its another name is the ultra capacitor. We can say supercapacitor or the ultra capacitor. This capacitor is called the ultra capacitor since it has a higher capacitance value than other regular capacitors. Because it is having a higher capacitance value, that it is called the ultra capacitor or the supercapacitor. The capacitor have low voltage limit, and these components are the choice over the regular type of the capacitor since they feature higher power density. So these components consume less power and are absolutely safe and easy to operate. So this supercapacitor are also called the ultra capacitor and is a high capacity capacitor with a capacitance value much higher than that of the solid state capacitor. Like the journal capacitor we will use, but these supercapacitor having the high capacity and high capacity capacitor, and they produce a higher value in a small power consumption. So it bridges the gap between the electrolytic capacitor and the rechargeable batteries. So it typically stores 10 to 100 times more energy per unit volume or mass than electrolytic capacitors, and can accept and deliver the charge much faster than that of the batteries. So nowadays the batteries are changed by the supercapacitor, which is having the more power as compared to the conventional batteries, and that tolerates many more charges and discharges cycles than the rechargeable batteries. Means we can have the charges and discharges cycles in the supercapacitor as compared to the regular batteries. Unlike the ordinary capacitor, supercapacitors do not use the conventional solid dielectric, but rather they use the electrostatic double layer capacitance. In the capacitor we use the dielectrics, then we produce a capacitor by using the two plates. But here in the supercapacitor we use the electrostatic double layer capacitance and the electrochemical pseudo capacitance, both which contribute the total energy storage of the capacitor. Basically capacitor is used for the storage. So by using this we can store the more energy. So supercapacitor are used in application which requiring many rapid charge and discharge cycle rather than the long term compact energy storage. Like in we use the charge and discharge cycle, where we use the automobile, we use it in the automobiles, buses, trains, cranes and the elevators, and they use the regenerative braking, short term energy storage, burst mode power delivery. We use these, for this we use the supercapacitors. Smaller units are used as a power backup for the static random access memory. So, that is SRAM, we use the static supercapacitors. Now, you see on the screen, this is the schematic illustration of a supercapacitor. You see, it is very easy to understand. In the previous lecture, we also discussed that these supercapacitor just use the two plates. One is the membrane, and it use the two electrolyte, and one is cation, second is anion, and the porous electrodes we use. Means when we prepare the supercapacitor, we use the electrode of various materials. It depends upon the type of the supercapacitor which we are preparing. So, you see on the screen here we are having the two electrolytes, and that are there is a current collector and one membrane is there, and it is connected with the battery, and this work as a supercapacitor. So, this is the schematic illustration of the supercapacitor. Now, if we talk about the history of the supercapacitor, it starts from the 1950, where the journal Electric Engineers began experimenting with porous carbon electrodes in the design of the capacitor. Previously, the porous carbon electrodes used as a capacitor from the design of the fuel cell and rechargeable batteries. Then activative charcoals is an electrical conductor that is an extremely porous, and that is porous means it is just like a spongy form of the carbon, and that carbon which can store the more energy in it. So, it is designed like that, and with this the specific surface area, the spongy form which is having a more high surface specific surface area for the storage. So, in 1950, if we say the active charcoals used, and because of its spongy nature and is one of the carbon form. In 1957, the low voltage electrolyte capacitor with the porous carbon electrodes were discovered, and the Becker explained that the energy was stored as a charge in the carbon pores as in the pores of the etched foils of the electrolyte capacitors. So, because of the double layer mechanism, it was not known at that time that it is not exactly just a component for the energy storage, but it leads to an extremely high capacity instrument. So, in 1966, Standard Oil of Ohio that developed the another version of the component, that is the electrical energy storage apparatus. That is while working on the experiment fuel cell design, then the nature of the electrochemical energy storage was not described in this patent, but they just explained the electrical energy storage apparatus. In 1970, electrochemical capacitor patented was done by the Donald Dell and registered as an electrolytic capacitor with activated carbon electrode. It means 1970 the activated carbon electrodes were used for the storage. So, early electrochemical capacitors uses two aluminum foils covered with the activated carbon, and that is the electrode, and that were soaked in the electrolyte and separated by a thin porous insulator. And we are having two electrodes, and that electrodes connected with that will be used for the energy storage. And this design gave a capacitor with a capacitance on the order of 1 farad. So, significantly which is higher than electrolytic capacitor of the same dimension. So, this electrochemical capacitor are giving the more output. So, this basic mechanical design remains the basic of the most electrochemical capacitor. After that, in 1991, in 1991, the difference of the supercapacitor and the battery behavior in the electrochemical energy storage was described, and in 1999, and then the term supercapacitor, it makes a reference to increase in observed capacitance by the surface redox reaction with the Faraday charge transfer between the electrode and ion. Then after 99, the supercapacitor used as the energy storage, and this supercapacitor stored electrical charge partially in the Helmholtz double layer and partially as result of the Faradic reactions with the pseudo capacitance. It means after the capacitance, one form of the supercapacitor defined as a pseudo capacitor, which partially have the Helmholtz double layer as well as the Faradic reactions. So that use as a pseudo capacitance charge transfer of the electrons and the protons between the electrodes and the electrolyte. This working mechanism of the pseudo capacitor are the redox reaction, intercalation, and the electroabsorption onto the surface defined by this pseudo capacitor. With this, then they define with the extended form of the electrochemical capacitor. Now, the recently developments include the lithium ion capacitor, and these hybrid capacitor were pioneered by the FDK in 2007, and they combined an electrostatic carbon electrode with a pre-doped lithium ion electrochemical electrode, and this combination increases the capacitance value, and additionally the pre-doping process lowers the anode potential and result in a high cell output voltage. If the anode potential is lower, then the output voltage will be high. So the pre-doping process done like that it lowers the anode potential and result in the high cell output voltage. Further, it increases the specific energy. Now, next term is that how we design the supercapacitor, that is also known as the electrochemical capacitor. These electrochemical capacitor, as we have seen in the diagram, that it is having the two electrodes, and these two electrodes are separated by an ion permeable membrane, that is the separator. We have seen in that diagram that we are having a two electrodes, and that will be separated by the ion permeable membrane, and an electrolyte ionically connected both the electrodes, means we connect the electrolyte with the electrodes, and in between that we are having a membrane. So when the electrodes are polarized by an applied voltage, ions in the electrolyte form electrical double layer of the opposite polarity of the electrodes polarity. Means when electrodes are polarized by an applied voltage, when we apply the voltage, the electrodes are polarized, ions in the electrolyte form electric double layers of the opposite polarity to the electrodes polarity. So, if we take an example, so positively polarized electrode will have a layer of the negative ion. If it is having a positive, then it will give the negative layer of the ions at the electrode. An electrolyte interface along with an charge balancing layer of the positive ion absorbing onto the negative layer. The opposite is true for the negative polarized electrode. There, the positive layer ions of the electrolytes interface along with the charge balancing layer of the negative electrode. Additionally, depending on the electrode material and the surface shape, some ion may permit the double layer becoming specifically absorbed ion and contribute with the pseudo capacitance to the total capacitance of the supercapacitor. Now, the typical construction of the supercapacitor, as we see on the screen, there are the 6 part of that, the typical construction of the supercapacitor. Number 1, as you see on the screen, that number 1 is the power source, that you can see that number 1 is indicated above on the top of that is the power source, that is a battery. Number 2 is a collector, that is on the left hand side, both the side we have number 2 means we have a collector. Number 3 is a polarized electrode. Just near the collector we have the polarized electrode, and these electrode are connected with the Helmholtz double layer on both the side. You see 4 there. Now you see the 0.5 is the electrolyte. After the electrodes we have electrolyte which are having a positive and negative ions. Then you see there is a positive and negative ions on the screen, and then we have a 6th one is a separator. That separator is a membrane also. Then this is the one form of the supercapacitor. So we have the 6 part in the supercapacitor. One is the power source, second is the collector, third is a polarized electrode, fourth is a Helmholtz double layer, fifth is a electrolyte having the positive and negative ions, and sixth is the separator. Now the capacitance distribution, if we have the 2 electrodes form a series of the circuit, as we know that we already know that we have the 2 individual capacitors like C1 and C2. Now the total capacitance C total is given by the formula like that, C total is equal to C1 into C2 divided by C1 plus C2. This is the capacitance distribution formula. Now the supercapacitor may have either the symmetric or asymmetric electrodes. If it is symmetric, then it implies that both the electrodes have the same capacitance value. In the symmetric we have the same capacitance value and yielding a total capacitance of the half the value of the each single electrode. Like we can have C1 is equal to C2, then we have the C total is equal to half C1. Now for the asymmetric capacitors, the total capacitance can be taken as that of the electrode with the smaller capacitance. If C1 greater than C2, then C total will be the C2. The total capacitance can be taken that of the electrode which is having the smaller capacitance. In here we are having a C1 is greater than C2 means C2 having a smaller capacitance. So we take the C2 as a total capacitance. So here we are having a 2 type of electrodes, symmetric and asymmetric. In the symmetric we have C total is equal to 1 by 2 C1 because both are equal. C1 and C2 are both the capacitance of the electrode are same, but here in the asymmetric we take the smaller capacitance of the capacitor. So C2 is having the smaller capacitance, so the C total is equal to C2. Now we discuss the storage principle, how we store the energy in these capacitors. So electrochemical capacitor uses a double layer effect to store the electric energy. Double layer effect means we are having a double capacitor. So electrochemical capacitor use the double layer effect to store the electric energy. However, this double layer has no conventional solid dielectric to separate the charges, and there are 2 storage principles in the electric double layer of the electrodes that contribute to the total capacitance of the electrochemical capacitor. So what is this double layer? Double layer capacitance where the electrostatic storage of the electrical energy achieved by separation of the charge in a Helmholtz double layer. Like if we take the double layer, so we achieve the separation of the charges in the form of the Helmholtz double layer, and pseudo capacitors where we are having electrochemical storage of the electrical energy. So the original type uses the Faradic redox reaction with the charge transfer. So we have the 2 type in which one is having the Helmholtz double layer and second having the Faradic redox reaction for the charge transfer. If we take the both the capacitances are only separable by the measurement techniques, the amount of the charge storage per unit voltage in an electrochemical capacitor is primarily a function of the electrode size. Although the amount of capacitance of each storage principle can vary extremely, but it depends upon the function of the electrode size. Now we discuss the types of the supercapacitor. We already have discussed the type, but here we discuss in the more detail that how many types of supercapacitors are there. So in the previous lecture we have discussed the just a brief idea about the different type of supercapacitor, but here we discuss with the full detail that electrical energy is stored in the supercapacitor by the two storage principle. We know that one is the static double layer capacitance and second is the electrochemical pseudo capacitance. Electrical energy can be stored in the supercapacitor by the two storage principle like electrochemical pseudo capacitance, and the first one is the static double layer capacitance. So the distribution of the two types of capacitance depends on the material and the structure of the electrode. What type of electrodes we are taking and what type of structure we are using for this. So on the basis of that, the output we will get. There are the three types of supercapacitor based on the storage principle. So in the type of supercapacitors we refer to as a gold capacitor, power capacitor, ultra capacitor or supercondensers. On the basis of their charge storage mechanism, they are classified into the three types. One is the double layer capacitor, second is the pseudo capacitor, and third is the hybrid capacitor. Hybrid capacitor we will make by using these two electrodes, double layer capacitors and pseudo capacitors. We will discuss further in the next lecture type and its application in various fields and how they all the supercapacitor work. We will discuss in the next lecture. Thank you very much.